Hello all, in this lecture we are going to discuss about an example for pumping lemma. So we need to prove that this language is not a context-free language. So first consider the given language is a context-free language. So let L be a context-free language, let N be a constant. Then we need to choose Z belongs to L. So Z is equal to 0 to the power 2 to the power P is equal to 0 to the power N. This 2 to the power, instead of 2 to the power P, we are going to consider N. So finally, we will replace N by 2 to the power P. And where length of Z is greater than or equal to N. So we have chosen length of Z like this. 0 to the power N is assigned to Z. Now split Z in the form of U, V, W, X, Y such that U, we need to assign values for U, V, W, X and Y. So U is considered as 0 to the power, actually Z has 0 to the power N. N number of zeros are assigned to Z. So out of N number of zeros, some Q number of zeros are assigned to U. Okay, so definitely Q must be less than this N. And VWX, now VWX is equal to 0 to the power some R number of zeros is assigned to VWX. So here R must be less than N minus Q, right? N is total number of zeros. Out of total number of zeros, N number of zeros, Q number of zeros are assigned to U, and from the remaining portion R is assigned to VWX. So definitely R is less than N minus Q. And another condition is here length of VWX is less than or equal to N. Then Vx is out of here R number of zeros are assigned to VWX. Out of this some number of zeros are assigned to Vx. So that is S. Okay, assume that 0 to the power S is assigned to Vx. So here definitely S is less than R. And length of Vx is greater than or equal to 1. At least 1 0 is assigned to Vx. Then Y. Y is equal to, here U has 0 to the power Q, VWX is 0 to the power R, and the total Z length is 0 to the power N. So Y can be written as 0 to the power N minus Q plus R. Now we can prove the third condition. So U V to the power I, W X to the power I, Y equals U V V to the power I minus 1, W X X to the power I minus 1, Y equals U V W X. We can combine Vx then Y. Now U is 0 to the power Q, VWX 0 to the power R, Vx is 0 to the power S to the power I minus 1. Then Y means 0 to the power N minus Q minus R, right? If we expand this, N minus Q minus R will come. Then we can expand this part. So 0 to the power Q, 0 to the power R, 0 to the power Si minus S, 0 to the power N minus Q minus R. Now we can simplify all are in the 0 to the power something, right? So we can combine everything. So this can be written as 0 to the power Q plus R plus Si minus S, Si minus S plus N minus Q minus R. So here plus Q minus Q plus R minus R are cancelled. So 0 to the power Si minus S plus N. So now pick I value equals 0. So U V to the power I, W X to the power I, Y equals 0 to the power. If we substitute I equals 0, we will get minus S plus N. Now we have to replace this N by 2P, right? So here N is equal to 2 to the power P. So this must be substituted now. So 0 to the power minus s plus 2 to the power p. But the language can accept 0 to the power 2 to the power I. Okay. But here minus s is added. So it is not belonging to L. So contradiction. Because this u b to the power I, w x to the power I, y must also belong to this language L. So here contradiction occurs. Hence the given language is not a context-free language. Thank you.